Hello everyone, welcome back to my YouTube channel. So I am starting a AI series where I will be talking about like how AI applications works, and also I will be talking about few interesting concepts which are necessary to understand the AI ecosystem. So in this video I will be talking about the embeddings. Okay, so let's start. Okay, so what I will be covering in this video. So obviously we will be seeing that what are embeddings, and then we will also talk about vector databases. Like this is just where we store the embeddings, but we will talk about more in detail. Uh, then we will see some real world application of the embeddings, like how people are using the embeddings, how what are the companies out there who are using these embeddings, and then I will talk about the practical example of the embeddings with some code. Okay, so what are embeddings? So if I just talk about the definition, so embeddings are numerical vector representation of the real world data, like text, images, or code that capture their meaning, context, and relationship in a way that machine can understand and compare. So, like machines or the models cannot just understand the raw text or the raw image. They need numerical data. So embeddings gives that functionality that they provide that numerical data to the machines. And the benefit of using the embedding is that if the text or the images share some common meaning or maybe some context, then they will be close to each other in the embedding space. Okay, maybe I will take an example to explain this. So let's say we have three sentences called "I love machine learning" or "Artificial intelligence fascinating," and "I enjoy cooking pasta." So, like you can see that first two sentences are quite relevant, while the third is the completely different. It says "I enjoy cooking pasta," which is has no correlation with the AI or ML model. So, okay, then embedding generation is something which is maybe I will talk about later in this video. But what happens that you just give the raw text or the raw input. It can be image, video, or text to the model. That model can be from OpenAI or any other company, and that model will give you the embeddings. So let's say I am giving the input as "I love machine learning." This is the text to some model, and that model is giving me the vector of some numbers like 0.15, 0.88, all these kind of numbers. And the dimension of this vector can be something like one from 128 to as high as some 5000 something. So it completely depends on the model, like which model you are using. So it gives some numbers, and this numbers model understand to figure out the similarity between different entities. Okay, so let me simplify this a bit. So let's say if I plot these numbers in a two-dimensional space. So previously it was giving like some n-dimensional numbers, so n-dimensional vectors. But let's say if we have only two numbers in the array, it's a two-dimensional vector. Then on the y-axis we have like AI relations, and on the x-axis we have like cooking related. So these first two statements like "I love machine learning" or "artificial intelligence fascinating," for these the coordinates would be much closer than the "I enjoy cooking pasta," because they don't have much correlation. So embeddings give you that feasibility that if the text or the images are kind of same, then they will be somewhat close to each other. That's the idea of the embeddings. Okay, so moving forward to like what are vector databases. So vector databases are again just specialized databases which are designed to store, index, and search high dimensional vectors efficiently. So okay, so what model is giving, right? Like the models are giving us the n-dimensional vectors, and now these vectors need to be stored properly in an optimized database so that we can query it uh, efficiently. So now there are a lot of databases available for vector like Pinecode and others. But why we are not using MySQL or NoSQL? What's the problem of using those kind of databases uh, for storing these numbers? So maybe that would require a separate discussion, which I will cover maybe in the next video. But just understand for now that these databases are highly optimized for inferencing or for querying the higher dimensional vectors. So yeah, this is like visual representation of what I told, that we are generating the embeddings, and these embeddings we are storing in a vector data store, and this data store can be like Pine or something like that. Okay, so here comes the big picture, like how exactly the things are working. So maybe you have used ChatGPT, and ChatGPT in ChatGPT you can provide your custom data as well that you want to answer. You maybe you want answers from some specific PDF or from some specific web page. So in ChatGPT you can like upload a specific PDF and you can answer that. You can answer cross questions from that PDF, right? So what happens behind the scene when you upload a PDF, and then how ChatGPT actually knows that okay, what's the data inside the PDF? So this is that's where the embeddings come into the picture. Like what happens is when you upload a PDF to the ChatGPT extract the content and create the embeddings of of the text from the PDF. So let's say a data warehouse is like a PDF. Maybe you can assume that where we have a lot of PDF. We pass this PDF to OpenAI embedding API where it generates the embeddings of the data, and then it store all the embeddings in some database which is a vector database. Here we are using the Pinecone, which is a very popular vector DB for storing the embeddings. Then let's say now if uh, you are using the chat gpt UI, right? It's an application, and you are putting some query, like maybe you uploaded a PDF for maybe your financial transactions, and now you want to know that how many transactions you did in the last month. So that would be your query. So now that query would be again converted to the embedding, which will again called by the OpenAI embedding API. It will create the embeddings for that query, and then that embedding will be used for query the Pinecone vector DB to fetch the near uh, like the similar kind of embeddings from the vector DB. So maybe it will be configurable that maybe you just need top 5 similar or maybe top 10 similar based on the score, and then it will return all those scores, all those documents back to the application, and then the application will decide that okay, which one to show and how to show. All those kind of things will happen. Okay, so practical use cases of the embeddings, like one is obviously semantic search, where we can create the embeddings of the query, and then we can match the similar embeddings from the vector DB. So it will give you the semantically same text or images or videos. The other thing is like the recommendation system, where maybe if people are watching some movies, and in the movie we have the genre information, title, maybe cast information, and those information we can match with uh, other movies. So those kind of things can also be done via embeddings. One is conversational AI. Like I just explained that how we are uploading a file to the chat GPT, and then we can cross question it with the chat GPT. So it is like conversational AI where we are passing additional information to the chat GPT. Chat GPT is creating the embeddings from that dog, and then is answering it. The last one is like the duplicate detection and grand clustering. It is again the same, where we have maybe some data, and we want to find the duplicate data. So if they are duplicate data, then the embeddings would be like in nearby circle only. So let's say if we have a data which is for which the embedding point is something in the vector space is like here. So for the duplicate data, maybe it will be very close uh, to its area. Okay, so coming to the demo, I will be referencing to the one code example which I found online. It is for the semantic search. So we will see like how semantic search will work in detail. Okay, so this is the reference which I am going to use. I will just link it with in my uh, caption so that you guys can access it. So first thing first, we need to set a few things. Like one is obviously the Pinecode client, which will be using to store the embeddings, and one is the OpenAI and the data sets, which will be use which we will using for creating the embeddings. Okay, so first thing is we need to create the embeddings now. So now to create the embeddings, we would need a model. That model can be anything from OpenAI or from Hugging Face or from somewhere else. We just need a model to give us the embeddings. So in this project, we are going to use the OpenAI model. So that's why we would need OpenAI API key. You can get that by checking your OpenAI profile, and you can get the API key from there. Now we just need to pass the model name, and then we can create our client and create the embeddings. So here, as you can see, we are passing the inputs as the text, and then we are passing the model name as well, and it is giving us some numbers, right? So it is giving a lot of numbers. I think it is more than 128. It seems more than 128. So these are the embeddings which I just explained. So if I just move, okay, so this is the length of the vector, like 1536. It is like this, that the length of the, or it is like 1536 the dimension of the vector. So like previously we were talking about two-dimensional vector, now it is like 1536 kind of dimensions. So the more the dimension, the better would be the precision, because the more information we would have. So it is better to have this much dimension. Okay, so once we created the embeddings, then what we need to do, we will be, if I just scroll down, now we need to store these embeddings in the database, so that for every query we can just refer the database. Otherwise, if we keep this thing in memory, then once our application restarts, all those things will be gone. So we need to store this data in the database. So as I explained, I am going to use Pinecone here. So again, we would be needing the API key for the Pinecone, which again you can get from the Pinecone dashboard. And in this code, nothing special we are doing. We are just creating the index name. We are passing the dimensions. Like in this case, it would be 1536. The metric we are defining as a dot product. It is like calculating the similarity between two embeddings. There are other kind of metrics as well, like Euclidean and cosine as well. So it depends on what kind of, on what basis you need similarity. Uh, so yeah, we are waiting for the index to be initialized, and then once the index is ready, we are connecting it. So this is the output that you will get once your index is ready. Like dimension 1536, index fullness is 0.0, namespace is empty, total vector count is 0. Now we have created the embeddings, and also we have created the indexes in my Pinecone DB. Now we need to populate the index with the data. So this is where we are creating the populating the data. We are loading the data sets, top 1000, first 1000 rows from the tracked data set, and then we are storing all this data with the batch size of 32 in my Pinecone DB, in my index. uh, and yeah, like once all the data is ingested in my Pinecone DB, and then we can query it using the same way which we use to create the indexes. So again, let's say if you have this query, you can again create the embeddings for this query by using the same command, client.embeddings.create. Here we are passing the query and the model name, and then we are getting the embeddings. So now once my embedding is ready, I just need to pass this embedding in my query to the database, and also I am mentioning that okay, I am interested in top 5, and then I am also mentioning that I am interested in getting the metadata. So what is my metadata in my Pinecone DB along with the embedding, right? So here we are also storing the text, like, so this was my input, right? Sample document text goes here. So this thing also we are storing in my Pinecone DB along with the embeddings, because that would be needed just to verify that okay, we are getting the right data. So we are querying it, and then if you like, you can see we are getting few matches where we are getting the ID metadata, where we have the text, and also we have a score, like how much similarity it has with this query. So yeah, like this is how the things work. You can use this data maybe to show on the UI, or to show some recommendations or something like that. Yeah, so that's it for this video. Let's meet in the next video. Thank you.